Hello guys, welcome back to the quantity surveying workshop and to another video. In today's video we're going to be treating how to measure the reinforcement inside of our beams. In our previous video we calculated how to measure the concrete that will be used to construct our beams. So it's only fair that in this video we learn how to calculate the reinforcement inside of the beams. So before we go right into the video, I'd like to make a special announcement. So the channel is officially monetized, meaning that viewers can now send super chats and super stickers. So these super chats and super stickers means to support the channel in a little way. This would help me stay motivated to keep on creating more educational content for you guys. And the monetization also gives me the privilege to create memberships for my viewers. So this membership is kind of like a platform where I post exclusive content for my members, strictly for members only. And to get access or to be a member, you'll be paying a monthly access fee to get access to this exclusive content. Now this exclusive content would come in the form of a more difficult measurements, be it building measurements, civil engineering measurements. So we're going to be treating all that strictly for members only. So just take it as it is a means to support me, and also you are going to be getting value for your money, because the videos that I'm going to be making are very, very, very important videos. Like, you hardly get them anywhere. So they're going to be touched on building measurements, more difficult building measurements, and civil engineering measurements. So if you would like to be a part of this community, or if you would like to see content like this, please, when the membership begins, it will be a privilege to have you guys on board. So without any further ado, let's get right into this video. So remember, in our previous video we treated how to measure for the concrete to our beams. Now in this video we're going to be learning how to measure for the reinforcement inside the beams. So like we said before in the video for calculating the concrete for the beams, they said that there were like about 14 beams. So if you haven't watched the video on calculating the volume of concrete for your beams, please, I would advise that you go and watch that video, because it has information that you are going to be needing. You hardly find that kind of video anywhere, especially on YouTube, because the kind of video concerning the measurements for the concrete work for the beams, I used a very, very complex drawing which you hardly find anywhere. So please, if you haven't watched the video, I would advise you go and watch the video. So you all know how to measure for your reinforcement. This is not the first time I'm measuring reinforcement in this channel. So reinforcement is measured in tons. So you have to first guess the total length of the reinforcement in meters, and then you do your conversion. So we're going to be starting from beam 1 down to the last beam to determine the length of each of the reinforcements. So we're going to be starting with beam 1. So now if you look at this drawing, this is your beam 1. So I'm going to zoom in so that you can see the orientation of the reinforcement. So now if you can look at this drawing, you can see that inside of the beam we have the reinforcement inside. I hope you can see this. So as you can see, inside of this beam like this, you can see that there are reinforcements inside, and the reinforcement they've already given out our call out. So you can see this reinforcement here for this section. You can see they say 4y16, right? Also this one here, there's a reinforcement intersecting this reinforcement here and this reinforcement here. So this reinforcement, now you can see they say 3y16. So the reinforcement is going to be 3 in number. I've already taught how to read and interpret all these callouts. So the 4 in the first place represents the number of the bar, y16 represents the size of the bar, and this is the number. So we're going to be starting with this bar. As you can see, how many bars do we have? we have this bar as 1, 4 in number, this other middle bar here 3 in number, and then this last bar here 4 in number. So we have another bar under. You can see this long bar from this point here down to this point. How many in number? 4 in number. You can see there's another one lapping it here under. How many in number? 4 in number, and they are all what? Y16. So after that, you are now going to see that they told us that from this point down to this point, we are going to be having what? Links at what? 200 what? Center to center spacing. And how many number do we have? They say that these stirrups from this point down to this point are going to be what? 66 in number, spaced at what? 200 center to center. And what is the size of the reinforcement? The size of the reinforcement is what? Y10. So these links or the stirrups, the reinforcement used for the links or the stirrups will be what? Y10. So I just hope you understand, how I read this drawing. So now how do we now measure the reinforcement inside this beam? So we're going to be starting with what? This reinforcement here from this point down to this point, and then with the bend. So now first things first, as you can see that the reinforcement does not reach the end of the beam. Why? Because remember that in concrete, the reinforcement inside of the concrete is supposed to be inside the concrete, meaning that it is supposed to be they are supposed to leave concrete cover, right, to allow for the concrete to cover the reinforcement, meaning that the reinforcement is going to end towards what? A concrete cover here, right, before you get to the edge of the concrete for the beam. So now how do we now get the length of this reinforcement? Now you can see that they say from this point down to this point is what? 1145. Now what we can do now is this. Since they told us that from this point to this point is 1145, we can now add from this point down to this point, which is what? Center to center dimension, which is 4008. So now after we get 4008 plus 1145, we are now going to add half of what? The thickness of this what? Column, because you know that this center to center dimension, right? So from here to here is half of the column, from here to here is half of the column, right? So once we get the house to house dimension from this point down to the edge of the beam, we will now minus what? Concrete cover. So meaning that once we minus the concrete cover, what we have now will be the length of the straight bar from this point down towards this end. Then we can now adjust by adding for what? Bend. So that is the procedure we're going to be using to determine the length of our what? Reinforcement. So now in a case where there's lapping like this point, now your lapping is between 600 to 1000 millimeters. So we're going to be using a lapping of 650 millimeters. So it means that this lapping here, this small lapping here, is going to be, but assuming that it's going to be what? 650 millimeters. So there'll be a lapping here, there'll be a lapping here, as you can see in the drawing. So from this point down to this point, the length of the reinforcement is what? 4580, as you can see here. So this one, we're going to be using the same approach as we did in this one. So with that, we can now begin our measurement. So first things first, we have to begin with what? This one here. So the first beam we're going to be looking at is what? Beam 1. So for beam 1, we're going to be starting with what? This reinforcement from this point down to this end. So now, like I said, like I explained before, we have to determine the dimension from this point down to the end of the beam. So now, how are we going to determine that? Now we're going to determine that by adding 1145, 4008, and half of the thickness of what? This column here. So 1145 plus 4008 plus half of what? 230, which is equal to what? 115. So now when you do the math, you're going to be having a total of what? 5268. So it means that the length from this point here down to the end of this beam is what 5,268. So now we're going to be minusing what concrete cover to give us the length of this trace back from this point down to this end, and we're going to be saying that our concrete cover is what 25 millimeters. So let's concrete cover. So now the concrete cover is going to be for one side, which is the concrete cover at this point here, because the reinforcement does not extend to the other side. So it is only one concrete cover we're going to be what minusing. So now let's what concrete cover, which is what 25. So when you minus it, you're going to be having a total of what 5,243. So now it means that 5,243 is the length of the word straight bar. Now we're not going to be adding what bend, because there's a bend here. So to add the bend, you know the formula. The formula is what 12D. So D is the diameter of the bar. So we'll now add what bend, which is what 12D. That's 12 by what? What's the size of the reinforcement? Y16. So that's 12 times what 16, which is what 192. So when you add 192 to 5,243, what are you going to be having? You're going to be having a total of what 5,435. So 5,435 is the length of this reinforcement from this point down to this what point, including what the bend. I don't know if that makes sense. So now remember that that 5,435 is the length for one reinforcement, or one of this type of reinforcement inside the beam. So now you will now go to your what call out and then determine the number of this particular one, and they say that they are what 4 in what number. So now you now note 4 number. I don't know if that makes sense. So 4 number, it means that this 5,435, we're going to be needing them 4 times to cater for what all the 4 reinforcement bar of this what size in beam 1. So now we'll now go towards this reinforcement, which is from this point down to this what point. So now as you can see, they told us that what from this point down to this point is what 4,580. So we want to determine what is the length of the reinforcement from this point down to this point, which is not given. So we can calculate that by minusing what 1,145 here and 1,145 here. So when we minus that, whatever we are left with will be the length of the reinforcement from this point down to this point. So this is reinforcement 1. So let me just name it R1. So the next one is what R2. So now to determine the length of R2 now, 4,580 will now less what 2 by what 1,145. 1,145 here, 1,145 here. I don't know if that makes sense. So when you do that, 2 times 1,145 is equal to what 2,290. So 4,580 minus 2,290 is equal to what 2,290. So now it means that the length of this reinforcement from this point down to this point, that's the length of the reinforcement at this center point, is 2,290. But remember that the reinforcement laps into the first reinforcement I've calculated. So we're going to allow for what lapping here and lapping here. And we said that we're going to be assuming that the length of the lapping is what 650 millimeters. So we'll now add lapping to both sides, which is 2 by what 650. So 650 times 2 is 1300. So when you do the math, 2219 plus 1300 is equal to what? 3590. So this is the length for what? R2 in beam 1. So the length of this reinforcement here, as you can see, going like this, ending here, is what? 3590. And how many are they in number? You can see they are what? 3 in number. So now write note. Three number. So the next one now we'll now do is what? This reinforcement here, from this point here down to what? This point here. So I'm going to be using the same process that we did for this reinforcement because they are similar. So we're going to be adding, we're going to be trying to get the length of this beam from this point here, which is the starting point of this reinforcement on the beam. So from this point here down to the end of the beam. And how do we do that? They've given us 2 dimensions. They say that from this point of the reinforcement down to this point is 1145, and then from this point down to the center point of this beam intersecting this column here is 4593. So we need to determine the length to the end of this beam here by adding half of what? The thickness of the column. So now we are not going to what? Measure. So we are going to be calling this reinforcement 3. So 1145 plus 4593. Then we're going to be adding what? Half of the what? Thickness of the what? Column, so that we can get to the end of the beam. So add half of what? 230, and that's going to be equal to what? 115. So when you do the maths, you're going to be having 5853. So it means that from the starting point of this reinforcement here, from this point down to the end of this beam is 5853. So we'll have to minus what? This concrete cover to get the length of the straight bar, and then we'll now add bend. So we'll now less what? Concrete cover, which is what? 25. So when you do the math, you're going to have 5828. We're now going to what? Add bend. So the bend, you know the formula, 12D. It is 12 by what? 16, and that's going to be equal to what? 192. So when you do the math, you're going to be having what? 6020. So the length of this reinforcement from this point down to what? This point, including the bend, is what? 6020. So now we're not going to do for this reinforcement here, from this point down to this what? Point. You see the reinforcement orientation inside. I hope you can see it from this, the starting point of this column down to this point, including the bend. So now how do we determine the length of this reinforcement from this point down to this point here, which is the straight point? You can see that they said we need to determine the length of this beam from this point of this column here down to the end of this beam. So how do we get the length of this beam from this point down to the end here? Now they've told us that the center to center dimension from this point down to this point is what? 4593. So we can add half of the thickness of this column to this point here, and then we can add half of the thickness of this column to this point here to give us what? The dimension from this outer side down to this what? Outer side. So I'm going to be naming that what? R4. So 4593 will now add what? 2 by half of the thickness of the column, which is 230 here, and that's going to give us what? 230. Now what this means is that since it is this dimension given here, center to center dimension from this point down to this point, which is the length of this bar from this point down to this point, what we're going to do now is that we've added half of the thickness of this column here and half of the thickness of this column here. So half of the thickness of the column is what? 115. So times 2 sides, that's what? 230. So when you do the maths, you're going to be having 4,823. So 4,823 is the length of the beam from that end, from this end down towards this end. So we're now going to be lessening the concrete cover at this side so that we can get the length of the straight bar, and then we can now add bend. So we'll now less concrete cover, which is 25 millimeters. So minus 25, we're going to be having 4,798. So 4,798 is the length of the straight bar. Then we'll now add bend. So 12 by 16 is 192. And that's going to give us 4,990. So doing this, we've measured for reinforcement 4 inside beam 1. And then as you can see, they say that this reinforcement is how many number? 4 in number. So let me just write this one. Reinforcement 3 is 4 in number. Note 4 in number, which is for this reinforcement here. You can see 4 in number. And then reinforcement 4 also is 4 in number. So the last reinforcement we're going to be looking at will be the reinforcement that is inside here from this point down to this end, including the bend. So now how do you determine the length of this reinforcement from this point down to this point? Now they told us that the center to center dimension from here to here is 4,008. From here to here is 4,580. So you can see the reinforcement enters and stops at the edge of this column, right? So we're now going to be adding half of the thickness of this column here. So we're adding 115 here and 115 here to get the length of this beam from this point here down to this end here. So when we now get our length, we'll now minus concrete cover and then add bend. So we're going to be naming that reinforcement 5. So 4,008 plus 4,580 plus 230, which is let me just see, we'll now add 2 by half of 230, and that's going to give me 230. When you do the maths, you're going to be having a total of 8,818, meaning that the length of this beam from this point here down to the end here is 8,818. So we're going to be minusing concrete cover for this side to get the length of this straight reinforcement from this point down towards this edge. So we'll now less. So 8,818 will now less concrete cover, which is 25. So 8,818 minus 25 is equal to 8,793. And then we'll now add bend. And we're going to be having 8,985. So this is the length for what? Reinforcement 5. So as you can see, we've measured for all the reinforcements in beam 1. So this is reinforcement 1, reinforcement 2, reinforcement 3, reinforcement 4, reinforcement what? 5. So now we're not going to what? Measure. So how many number of reinforcements 5 did we have in this drawing? You can see they say it is what? 4 in number. So we'll now write it down. 4 in what number? So now we're not going to go to get the total length of the reinforcement in what? Beam 1. So now, what was the length we got in reinforcement 1? 4,535, and they are what? 4 in number. So you convert this to meters. That's 4.2. That is 5.44. So you will now book by saying what? R1 is equal to what? 5.44. And they are how many in number? 4. So multiply by what? 4. I don't know if that makes sense. And then you close. Then R2 is how many? What is the length? You can see the length is what? 3,590. And they are how many in number? 3 in number. So you convert it to meters. That's 3.59. So 3.59 multiplied by what? 3. And then you what? Close. The next one is reinforcement what? 3. And they say that the length of reinforcement 3 is what? 6,020, which is what? 6.02. 6.02. And they are how many in number? 4 in what number? So the length for reinforcement 4, we calculate it as what? 4,990, and they are what? 4 in number. So we'll measure. That's 4.99, and they are what? 4 in what number? And then you close. So reinforcement, so that's reinforcement 4. So reinforcement 5 now is what? 8,985, which is what? 8.99 in meters, and they are how many in number? 4 in number. So you now what? Close. Now let's get the total of all these measurements that we've already done here. So 5.44 multiplied by 4 is what? 21.76. 3.59 multiplied by 3 is what? 10.77. 6.02 multiplied by 4 is what? 24.08. 4.99 multiplied by 4 is what? 19.96. 8.99 multiplied by 4 is what? 35.96. So now when you add everything here, you're going to get the total length of reinforcement you'll be needing in beam 1. So 35.96 plus 19.96 plus 24.08 plus 10.77 plus 21.76. You are going to have a total of 112.53 meters. So total is what? 112.53 meters. So this is the length of reinforcement you are going to be needing in beam 1. So you can either convert this in tons now, but what I want to do is that I want to get all the length of the reinforcement from beam 1 down to the last beam, add everything together. Once I get the total length of the reinforcement, then I will now convert everything to what? Tons. So as you can see, this is beam 2, and it is straightforward, very straightforward. We only have 2 kinds of reinforcement, or one reinforcement which are the same. As this reinforcement on top is the same with reinforcement under. they are 3 in number and it's y16. Also the one under is what, 3 in number and it is y16. So we can get the length of 1 multiplied by the number, which is 3, and then multiplied by what, 2. So how do we get the length of this reinforcement? To determine the length of this reinforcement, they told us that the center to center dimension from here to here is 4008. So we need to get the length of this beam from this end down to this end. So we can do that by adding half of the thickness of what, this column here, which is what, 230, which is 230. So when you divide 230 by 2 is what, 115. So we'll add 115 here, 115 here, to give us the length of this the length of this beam from this point down to this point. So when you now do that, you will now minus what's concrete cover from both sides. When you minus concrete cover from both sides, you're not going to be adding bend on both sides, because we have a bend here and we have a bend here. So with that, you can now what, measure. So for beam 2, to determine the length, we now say 4008. We will now add half of the thickness of what, the beam or the column. Add half of the thickness of the column, which is 230, on both sides, and that will be what, 230. So when you do the math, you are going to be having a total of what, 4238. So 4238 is the length of the what, beam. We will now less what, concrete cover, to get the length of the straight bar. So the concrete cover is going to be on both sides. So 2 by what, 25 is equal to what, 50. So 4238 minus 50 is equal to 4188. So 4188 is the length of the straight bar. We'll now add what, bend. So the bend will now be what, 2 by 12 by what, D, which is 16. Remember, we're adding bend because the bend is found on the two sides of the reinforcement, here and what, here. So 2 times 12 times 16 is equal to what, 384. So 384 plus 4188 is equal to what, 4572. 4572. So 4572 is the length of this what, reinforcement inside of what, beam 2 here. And there are how many in number? 3 in number. So you now write notes. 3 in number. So now with this, we can now what, measure. So you convert this to meters. 4572 divided by 1000 is what, 4.57, right? So now, how many number do we have? There are what, 3 in number, both on top and both under. So the top reinforcement here is 3 in number, the bottom reinforcement here is 3 in number. So you can either multiply this by 6, or you can multiply it by 3 for the first one and then multiply it by what, 2. It also works. So 4.57 multiplied by 3 multiplied by 2 is equal to what, 27.42. So it means that we're going to be needing a reinforcement of what, 27.42 to what, make the reinforcement for beam 2. So total is equal to what, 27.42. So with these, we've measured the total length of the reinforcement in meters that will be used in beam 2. So we'll now move to beam 3. In order for us not to, keep measuring the same thing 2 times, you have to, be smart when you are reading your drawing. Now, if you look at this, if you look at beam 2 and what, beam 5, what can you see? They are what, the same thing. The dimension here is the same. The dimension here is the same. the number of the reinforcement is the same, 3. The number of the reinforcement is the same here, 3. Similarly, the number of the reinforcement under, meaning that the length of the reinforcement will be calculated for beam 2 will be equals to the length of the reinforcement will be needing for beam 5. Now remember, when we're calculating for our concrete for beam 2, we said that beam 2 is equal to what? Beam 5, meaning that the volume of concrete in beam 2 will be equal to the volume of concrete in beam 5, meaning that also the reinforcement in beam 2 would also be the same reinforcement in what? Beam 5. So let me just bring the previous measurements on this thing that we did, so you can see, note, beam 2 is equal to what? Beam 5. So instead of measuring the reinforcement for beam 5 again separately, which is basically the same thing that we've done here for beam 2, you will just come here and what? Just bring everything down again. You will just say, note, beam 2 is equal to what? Beam 5. Therefore, we will now say beam 5, the total length of reinforcement is equal to what? The same 27.42. I hope that makes sense. Now, I just want to make you know that this method that we just did now, you have to watch your drawings. You have to check your drawings properly to make sure that the reinforcements used are what? The same. So we use this approach because reinforcement in beam 2 in the drawing was the same as reinforcement in what? Beam 5. Don't just use the fact that, okay, because of the length, the volume of the concrete used in beam 2 is the same as the volume of the concrete used in beam 5. Then you will not assume that the reinforcement in beam 2 will be the same as reinforcement in beam 5. Now let us look at this example. Remember, we did beam 1, right? And in our previous video where we did the measurements for the concrete for the beams, we said that beam 1 is equal to what? Beam 7, meaning that the volume of concrete in beam 1 will be the same as the volume of concrete in beam 7. Now let us compare and contrast the reinforcement in beam 1 and that of what? Beam 7. Now you can see that the dimension that they're giving us in beam 1 is 4008, 4580, 4593. This point here is 1145, and this point here is 1145. But now let us look at what? Beam 7. You can see beam 7, 4008, 5140, 4033. Even though the volume of the concrete is going to like be equal with beam 1, right? You can see that the length of the reinforcement, how many reinforcement do we have in beam 7? 1, 2, 3, 4, and what? 5. The length of the reinforcement could differ because you can see that the dimensions are kind of different in, you know, different places of the what? Reinforcement. So you have to what? Be careful when you are what? Measuring your reinforcement in that manner. So in this case, we are going to be doing beam 7 what? Separately. So the next beam we're going to be looking at now will be beam 3. So we want to determine the length of the reinforcement in beam 3. So how many reinforcements can we see? So for beam 3, you can see that we have these reinforcements from this point here, 1, from this point here, this long one, 2, and then the under one, which is this one here, 3. So they say that this first one, they are how many in number? 3 in number, they are Y16. This one here, they are how many in number? 4 in number, and they are Y16. And this long one, they are how many in number? 4 in number, and they are what? Y16. So we have to determine the length of this reinforcements, the 3 reinforcements inside of what? Beam 3, starting with what? This one. So how do we get the length of this reinforcement here from this point down to this point, including the bend? So they told us that from this point here, down to this point is 4580, right? But our reinforcement does not reach this point. It stops here, right? This lapping here. So what we can do is this is what the approach you can use. we can get the total length of this beam from this point down to the end. That's from this halfway down to the end by adding half of the thickness of this column here. That will give us the dimension from this center point down to the end of this beam. So when we do that, we're now going to minus this dimension here. So this, when we minus the dimension, it means that we're going to be getting the length of this beam from this point here down to this end of the beam. Then we're now going to be minusing concrete cover. When we minus concrete cover, we're going to be getting the length of the straight bar from this end down towards this end, and then we're going to be adding lapping, this lapping here. When we add this lapping here, we're now going to add bend for this side. So that's the process we're going to go about measuring beam 3. So now let's do the maths. So 4,518 we will now add half of the thickness of this column here to get us to the end of that beam. So plus 115, and that's going to give us 4,695. So it means that from this point down to this center point down to the end of this beam is 4,695. So what we're now going to do is that we're going to be minusing this dimension here, which is 1,145. So less 1,145, which is 3,550. So this 3,550 is the length of this this beam from this point here down to the end, to the edge of this beam, right? So now we'll now minus concrete cover for one side. So less concrete cover, which is 25. So minus 25 is 3,525. So it means that this 3,525 is the length of this reinforcement from this point here down to this point here. So we'll now add this lapping, and then we'll now add bend. So we'll now add lapping, and our lapping, we said this was 650, and then our bend is 2. Our bend is 12 by 16, which is 192. So when you do the maths, 3,525 plus 650 plus 192 is equal to 4,367. So 4,367 is the length of the reinforcement for reinforcement 1 in beam 3. So this reinforcement you see like this, going like this, that's reinforcement 1. And there are how many in number? There was 3 in number. So note 3 in number. So the next reinforcement we're going to be looking at is reinforcement 2 of beam 3. So reinforcement 2 now, you can see this reinforcement 2 from this point down to this point here, including the bend. So now how do we get the length of this reinforcement from this point down to this point? What we can do is to get the length of the beam from this point down to the end. So they've given us 2 dimensions, 1,145, 4,593. So we can add the 2 of them together, and then we can add half of the thickness of this column here to get us to the end, to the edge of this beam. So let's do the maths now. We'll call this R2. So R2 is 1,145 plus 4,593. We're going to be having 5,738. So 5738 is the length of the is the length of this this dimension from this point down to this point. So we're going to be adding what? This half, the half of that column to get us to the edge. So we'll now add 115, which is half of the thickness of the column. 230 divided by 215. So plus 115, we're going to be having 5623. So it means that 5623 is the length of this beam from this point down to the edge. Right? So what we'll now do now is to minus what? Concrete cover, to give us the length of the straight bar from this edge down to this edge. So now less concrete cover, which is what? 25. So minus 25, I'm going to be having 5598. So 5598 is the length of the straight bar for this reinforcement 2. From this point to this point, they will now add bend. So we'll now add bend, which is what? 12D. 12 by what? 16, which is 192. So when you do the maths, 192 plus 5598 is equal to what? 5790. So 5790 is the length of what? Reinforcement 2 in beam 3. So this is the reinforcement we just measured here. So the next reinforcement we have to measure is this reinforcement under. So how do we get the length of this reinforcement? We need to determine the length of this beam from this point down to this point. Then we'll minus concrete cover from both sides, and then we'll add bend to the both sides. So reinforcement 3. So reinforcement 3 now will be calculated by adding 4518 and 4593 together. Then we'll now add half of the thickness of the column here and here. So 4518 and 4593. Then we'll now add 2 by half of 230, which is equal to 230. So when you do the maths, you're going to be having 9403. So 9403 is the length of this beam from this point down to this point. So we'll now minus concrete cover from both sides and add bend to both sides. So less concrete cover, which is 2 by 25, and that's 50. And then we'll now add bend. So minus 50 is equal to 9353, and then bend is 12D. So to both sides, 2 by 12 by 16. So 2 by 12 by 16 is 384. So 384 plus 9353 is equal to 9737. So 9737 is the length of reinforcement 3 in beam 3, which is this reinforcement under here. This reinforcement under here, and they see there was 4 in number, while this one too is also 4 in number. So note. Doing this now, we'll now record all the reinforcements to get the total length in meters for the reinforcement in beam 3. So for reinforcement 1, they said that you have what 4,367. So you convert it to meters, which is what 4.37. 4.37. And they are how many in number? There was 3 in number. So you multiply it by what 3. And then you close. The next reinforcement, they say is what the length is 5,790. So you convert it to meters and multiply it by the number. So we're going to be having what 5.79 multiplied by what 4 number. And then the last one is what this, the longer one, 9,737 converted to meters, which is what 9.74. And they are how many in number? 4 in number. So when you do the math, 4.37 multiplied by 3 is equal to what? 13.11 meters. 5.79 multiplied by 4 is equal to what? 23.16. 9.74 multiplied by 4 is equal to what? 38.96. So now when you add everything together, (38.96) plus 23.16 plus 13.11, you're going to be having a total of what? 75.23. So the total reinforcements needed to make beam 3 is equal to what? 75.23 meters. So I hope this is easily understood. So we'll now move to the next beam. So the next beam we're going to be looking at is what? Beam 4. So now, how many reinforcements do we have in beam 4? We have, this is 1, this center one here is 2, this one here is 3, this one here is 4, this one here is what? 5. They are what? 5 in number. So you can see that this one, they say there are how many, this length of reinforcement here is how many in number? 3 in number, and it is Y16. This center one here is how many in number? 2 in number, and it is Y16. This long one here is how many? 4 in number, and it is what? Y16. This one here is what? 4 in number, and it is Y16. And this long one here is what? 3 in number, and it is what? Y16. So we are going to be using this now to what? Measure. How do we measure for this reinforcement inside here? We'll use the normal approach. They've given us, we need to determine the length of this beam from this point here down to this end of the beam. So we can now add 986 and 4008, then half of the thickness of this column here to get us to the edge of this beam, right? Now when we do that, we'll now minus concrete cover, and then we'll now add bend. I hope that makes sense. So for beam 4, we'll now add 4008, 986 and 115 together, and that will give us what? 5109. So it means that the length of the beam from this point down to this end is 5109. So we'll now minus what? Concrete cover. So we'll now see less concrete cover, and we'll be minusing concrete cover from one side, so minus 25. That will give us what? 5084. So we'll now add bend. So our bend is what? 12D, which is 12 by 16, which is 192. So when we add 192 to 5084, we're going to be having what? 5276. So 5276 is the length of the reinforcement 1 in beam 4, which is this reinforcement here. And they say there are how many in number? 3 in number, right? As you can see in the callout. So note 3 in number. So we'll now move towards reinforcement 2. So still on beam 4, we'll try to measure reinforcement 2, which is this short reinforcement here. So how do we get the length of this short reinforcement? They told us that from this point to this point is 3943, and they told us that from this point here is 986, and this point here is 980. So we can minus this 986 from these two sides. Whatever we have will be the length of this reinforcement from here to here. Then we'll now add this overlap here and this overlap here. So now let's do the maths. 3943 will now less what 2 by what 986, which is 1972. So 3943 minus 1972 is equal to 1971. So it means that 1971 is the length of this bar from this point down towards this point. We'll now add what overlap, and we're assuming that our overlap is what 650. So add lap. So the lap will be on two sides, so it's 2 by what 650, and that's what 1300. So 1300 plus 1971 is equal to what 3271. So 3271 is the length of this straight bar in the middle. And they say they are how many in number? 2 in number. So note 2 in number. So doing this, we've measured the length of reinforcement 2 in beam 4. So we'll now go to reinforcement 3. So for reinforcement 3, which is this reinforcement here, right, you can see that it is the same procedure as reinforcement 1, it's just that it is longer. So how do we get the length of this reinforcement? First thing, we need to determine the length of this beam from this point, this dimension line here, down to this dimension line, and then we'll now add the thickness of we'll now add half of the thickness of the beam to get us to this edge. Because remember, there's going to be a beam here and the thickness is 230. So half of 230 is 115. We'll have to add 115 here to get us to what? This edge of the what? Beam. So once we get to this edge of the beam, we'll now minus what? Concrete cover, and then we'll now add bend. So we'll now say 5230 plus 986, then plus half of the what? Thickness of the what? Beam, which is 115. When you do the math, you're going to be having what? 6331. So 6331 is the length of this beam from this edge down to this edge, right, the external side. So we'll now less concrete cover to get us the length of the what? Straight bar. So minus 25, we're going to have what? 6306. So 6306 is the length of this what? Straight bar from this point here down to this end. So we'll have to add this bend. So add bend, which is what? 12D. So 12 times 16 is equal to 192. So 6306 plus 192 is equal to 6498. So 6498 is the length of the reinforcement we're going to be needing for what? Reinforcement 3, which is this reinforcement here. And there are how many numbers? You can see in the colors, there are what? 4 in number. So note 4 in number. So doing this, we've measured for reinforcement 3 in beam 4. We'll now go to reinforcement 4. So how do we get the length of reinforcement 4? So as you can see, reinforcement 4 spans from this edge of the what? Column here down toward this end, including the word bend. So we have to determine the length from this end down to, we have to determine the length of this beam from this edge of the column down to this edge of this side of this beam here. Then we'll now minus what concrete cover from here, and then we'll add our bend. So they've given us this dimension from here to here, which is center to center dimension, as 5,230. So we're now going to be adding half of the thickness of the column here and half of the thickness of the column here. So once we do that, we'll be getting the length of this beam from this edge down to this external side here. They will now minus what concrete cover and add bend. So let's do the math. So 5,230 will now add what 2 by half of the thickness of the column. So 5,230 plus 5,230 is what 5,460. So it means that this 5,460 is the length from this point of this column down to this point of this column here. So we're now going to be minusing what concrete cover from one side, because the reinforcement for reinforcement 4 spans from the edge of this column down towards the starting point of the concrete cover. So we'll now less what concrete cover. So we'll now less concrete cover, which is what 25 mm. So 5,460 minus 25 is equal to 5,435. So 5,435 is the length of the reinforcement from this point down to this end. So we'll now add bend. So which is 192. So 5,435 plus 192 is equal to what? 5,627. So 5,627 is the length of reinforcement 4 of beam 4. So this reinforcement here is reinforcement 4, and they say they are how many in number? They are 4 in number. So you write note 4 in number. So the last reinforcement for beam 4 is reinforcement 5. So now this reinforcement now spans from this point down to this point, including the word bend. So how do we get the length of reinforcement 5, which is this reinforcement here? Now they've told us that they've given us the length from this point down to this point, and from this point down to this point, right? So we need to determine the length of this beam from this edge of the column down towards this edge of the column here. And how do we do that? They've told us 2 dimensions to get the center to center dimension from here down to here. So when we add these 2 together, we'll get the total center to center dimension from this point down to this point. Then we'll now add half of the thickness of the column here and half of the thickness of the column here. So once we do that, we'll be getting the out to out dimension as from this outer side of the column down to this outer side of the column. Don't know if that makes sense. So doing that, then we will now minus what concrete cover. Once we minus concrete cover, what we have will be the length of the reinforcement for the straight bar from this point down to this edge, and then we'll now add bend. So 3,943 plus 4,008 plus what 2 by half of what 230, which is what 230. That's going to give me 8,181, meaning that the length from this edge here down to this edge here is what 8,181. So minus what concrete cover from one side. Which is what 25 millimeters. So 8,181 minus 25 is equal to what? 8,156. So 8,156 is the length of the straight bar. We'll now add bend. Which is what? 12D, which is 12 by 16, and that's 192. So 192 plus 8,156 is equal to what? 8,348. So 8,348 is the length of this reinforcement. That's reinforcement 5 here of beam 4. And they say they are how many in number? They are 3 in number. So you now write note. Three in number. So with this, we are done for all the reinforcement in beam 4. We can now begin to record. So the first one is what? 5,276 in meters is what? 5.28. So we'll record 5.28, and they are how many in number? 3 in number. So multiplied by what? 3. And then you now close. So reinforcement 2, 3,271 in meters is 3.27. So you write 3.27, and then they are how many in number? As you can see, they are what? 2 in number. So you multiply it by what? 2, and then you close. Reinforcement 3, what do we have? 6,498 in meters is what? 6.50. So write 6.50, and then how many in number? 4 in number. So multiply by 4, and then you close. Reinforcement 4, what do we have? 5,627 in meters is what? 5.63, and then how many in number? 4 in number. And the last reinforcement is reinforcement 5, 8,348, which is 8.35, and they are 3 in number. So now let's do the maths. 5.28 times 3 is equal to what? 15.84 meters. 3.27 times 2 is what? 6.54 meters. So 6.50 times 4 is what? 26 meters. 5.63 times 4 is what? 22.52 meters. 8.35 times 3 is what? 25.05 meters. So when you add everything together, what are you going to be having? You are going to be having the total of what? 95.95. So it means that the total reinforcement you are going to be needing here is 95.95. So the total reinforcement needed to make all the reinforcements in beam 4 is 95.95 meters. So with this, I'm sure you understand the process. As you can see, the video is already hitting more than 1 hour now, so we won't be able to complete the whole reinforcement inside of this drawing. So it means that we're going to be stopping here for this video. So the process is similar to all the reinforcement here when you're trying to measure the length of the reinforcement for the beams. So you continue doing the same process until you've measured for all the reinforcements inside these beams. Then you add everything together to get the total length of all the reinforcement, and then you convert it to tons. I'm sure this is not new to you if you have been on this channel. Conversion of reinforcement from linear meters to tons shouldn't be a difficult thing. So you continue the process till you finish all the reinforcement inside of the beams. The process is also the same when you're talking about measuring for your concealed beams. So before I end this video, I just want to make a reminder that I'll be creating my membership soon, and it will be a privilege to have you guys on board. So please support me when the membership is made public. I would love that you guys join. It will really help me a lot to support me to keep going. And you can also support me by sending a super chat or a super sticker. It will really go a long way for me. I also noticed that the videos for stirrups and sometimes formwork doesn't really do well. So if you want me to make a video on how to measure the reinforcement used to make the stirrups for the beams, please I would like you to state in the comment section so that I can make the video.